Good day, everybody. How are you all doing? Those of you who do not know me, this is Dr. Nandi. I frequently go live on YouTube. I also have a YouTube channel where I have uploaded all kinds of travel videos and all kinds of math videos. People often complain that math is difficult. Yes, math is difficult. There's no easy way out. But if you realize what you are doing, if you understand the process, then it is not that difficult. So I request you to watch through my videos without quitting halfway through. Today I will derive the formula for binomial probability distribution. Now, it's a big name, binomial. What is a binomial distribution? For example, when you toss a coin, it's a binomial probability experiment. Why? Bi means two. There are two possibilities or two outcomes possible or two results possible when you toss a coin. Either you get a head side up or you get a tail side up. Hence, this is a binomial experiment because it has two possible outcomes. So, we'll work with tossing a coin three times, a fair coin. A fair coins which has same weight on the head side and on the tail side. We'll toss that coin three times. So, what are the particular possibilities when you toss a fair coin three times, one after another? So, you can get all heads, for example, or you can get two heads and a tail, or you can get a head, tail, and a head, or you can get all heads as I said first, or you can get two tails and a head, or you can get a tail, head, and a head, or you can get entire all three tails, okay, or you can get a tail, head, and tail. Why are these three? Because remember, you're tossing the coin three times. In this case, in the three tosses, all are heads. First two are heads, the third is tail. First one is head, second one is tail, third one is head. In this case, first two are tails, last one is head. In this case, the first toss is tail, the next two are head. In this case, tail, tail, tail. And all three are tails. And this is tail, head, tail. Okay. So we have one more to go. And what is that, you think? This is this one, which is the first one is head. And the next two are tail. So there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities. 8 possibilities. Suppose I'm interested. So toss a fair coin three times. Three times. Suppose I'm interested to find out what is the number of heads in each toss. Number of heads. Now in this one, number of heads is 3. In this one it is 2. In this one it is 2. In this one it is 1. In this one it is 2. In this one there is no tail at all, 0. In this one it is 1. And in this one, this is 2. Okay. So these are all the possible combinations of tail and head that you can get when you toss a fair coin three times. So we are looking at the probability distribution of number of heads. Okay. So as you can see, the lowest value is 0, the highest value is 3. So, and there are 8 chances, 8 possibilities. As you see over here, 1, 2, 3, 4, 5, 6, 7, and 8. Now we will look at the probability of each. So if we look at number of heads, the lowest value is 0, The highest value is 1, the next value is 2, the lowest value is 0, next is 1, next is 2, and the highest is 3. How many times 0 appears? Okay, probability of each. Now probability is nothing but proportion or relative frequency of each event. 0 head occurs 1 out of 8. 1, 2, 3, 4, 5, 6, 7, 8. 0 head occurs only once. So its probability is 1 out of 8. Why 1 out of 8? Because out of each of these 8 possibilities or outcome and happen, and they're equally likely to happen. So probability of each is the same, or in this case 0 is 1 out of 8. How many times 1 appears? Twice. So it is 2 out of 8. How many times 2 appears? 1, 2, 3. So it is 3 out of 8. Let me see if I have done it correctly. Yeah, 2 appears 1 time, 2 time, 3 time. Okay, and 1 appears, actually 2 appears 4 times, so it is 4 out of 8. And how many times 3 appears? Only once, this one. Okay, so 3 appears 1 out of 8. Okay, so if you write this in fraction or decimal, this is already in fraction 1 out of 8. In decimal, this is 0.125. This is 2 out of 8 is 0.250. This is 4 out of 8 is 0.50. And again, this is 0.125. So these are the probabilities of each of these possibilities. Now we have to calculate the mean of this. So this is a discrete probability distribution. This is a discrete probability distribution. Why? Because the number of heads goes all the way from 0 to 1 to 2 to 3. The jump in number of heads is from 0 to 1, discrete of jump of 1. Then from 1 to 2, discrete jump of 1. Then from 2 to 3, discrete jump. You cannot have fractional heads. And this is a discrete probability distribution. For a discrete probability distribution, what is the probability discrete probability of number of heads? Of number of heads in 3 tosses. In 3 tosses. So you can think of this as x, number of heads, and this is the probability of x. So let's multiply x times px. X is what? Number of heads. So the first one is 0 times 0.125 is 0. Next one is 1 times 0.25 is 0.25. Next one is 2 times 0.5 is 1.0. Okay, and the next one is 3 times 0.125 is 0.375. Now the mean of a discrete probability distribution that is the center is obtained. Probability distribution mu is sum of x times px. Again, this is sigma, that means sum, Greek capital S. So it is 0 plus 0.25 plus 1 plus 0.375. Okay, and that will be equal to, so 0.25 plus 1 . plus 0.375, and that is equal to 1.625. Does it make sense? Let's check on that. Okay, so 0 head is 1 out of 8. Okay, 2 heads appears this. This is not 2. I made a mistake here. This is 1 head only. Okay, so 1 appears 3 times, 2 appears 3 times. So that's why the numbers are not matching up. Okay, so 0 appears 1 out of 8. 1 appears, 1 head appears how many times? 1, 2, and 3. So it is 3 out of 8. So it is 3 out of 8. Okay, then that is equal to 0.375. 2 appears how many times? 2 also appears 3 times. So 3 out of 8 is 0.375. Okay, and 3 appears only once. Okay, so it is 1 out of 8 is 0.125. Okay, so now we are multiplying this x times px. The first one is 0, second one is 1 times 0.375 is 0.375. Next one is 2 times 2, x value is 2 multiplied by 0.375. So if you want me, I can write this down a little bit. So first one is 0 multiplied by 0.125 is equal to 0. Next one is x value is 1 multiplied by 0.375, which is 0.375. Next one is 2x value times 0.375, and that's 0.75. And the next one, last one, is 3 multiplied by 0.125, and it is 0.375. 375. So let me write that a little bit smaller. So that is equal to 0.375. Now we will add all of this. This column I'm going to add. So it is 0 plus 0 plus 0.375 plus 0.75 plus 0.375. Okay, and the sum is of all these three numbers is 1.5. 1.5. This 375 plus 0.75 plus 1 is 1.5. So that being the case, that is the mean. Actually, for binomial distribution, mean is given by n times p. What is p, you ask? P is the probability of success in each trial. Probability of success in each trial. Now in this case, we are tossing the coin. So probability P is the probability of getting a head in each toss. Probability of a head in each toss. Is 0.5, we know, in the long run. So P is 0.5. And remember, we are tossing the coin 3 times. So mu is equal to n times p. We toss the coin 3 times, so n is 3 and p in the long run is 0.5 is equal to 1.5. So, and we proved that for binomial distribution, mu is equal to n times p, and actually mu is also equal to, because it's a discrete probability distribution, sum of x times p. What is x? Number of successes or number of heads in this case. And x in this case runs from 0 head, 1 head, 2 head and 3 heads. Okay, so this is the mean of binomial distribution. Okay, let's do another thing. Let's find out the variance of binomial distribution. So again, here we prepare a small table. X, we know 0, 1, 2 and 3. Okay, we know the corresponding probabilities values, which is 0.125, 0.375, 0.125 and the last one, no, this is 0.375 and this is 0.125. Okay, yeah, because 1 appears 3 times, 1, 2, 3, 1 head. 2 appears also 3 times, hence the probabilities are same of this. Okay, now what we will do, we will calculate x minus mu. So for example, this one will be 0 minus mu, already we have established is 1.5. So this is minus 1.5. This one will be 1 minus 1.5 or minus 0.5. This one will be 2 minus 1.5 is 0.5. And this one will be 3 minus 1.5 or 1.15. Now we will square this quantity, x minus mu square. So you know negative numbers, when they are squared, multiplied by themselves, one negative number multiplied by another negative number is positive. So 1.5x squared is 2.25. 0.5 squared is 0.25. This is 0.25 and this is 2.25. So we squared these, okay? So 0.5, just want to make sure is 0.25, correct. Now we will multiply the squares with the corresponding probabilities. The probabilities will come from here, and these numbers, this column will be multiplied by this column, which will be for the first one. So we are multiplying 2.25 times 0.125. And that is 0.28125. Next one will multiply 0.25 times this time. Okay. So next one is 0.25 times 0.375. And that is 0.09375. Let me write it clearly. 0.09375. Okay, 0.09375. Next one, this one multiplied by this same 0.09375. And next one multiplied by this same as the first one, 0.28125. Now for discrete probability, for discrete probability distribution. Here we have a discrete probability. Why? Because we are jumping from 0 to 1 head, 1 to 2, 2 to 3 heads, and so forth. For discrete probability distributions, okay, variance, square means variance, is equal to sum of x minus mu square times probability, which we did. So basically we have to add this column up, okay, the last column. So sigma square will be equal to 0.28125 plus 0.09375 plus 0.09375 plus 0.28125. So sigma square will be equal to 0.28125, that is twice 0.28125 times 2 plus this quantity twice 0.09375 multiplied by 2, and the answer is 0.75. How does it match up with the formula? Formula for binomial distribution, which is true in our case. Sigma square is equal to n times p times 1 minus p. So sigma square, we are tossing the coin 3 times. Probability of success in each trial is 0.5, and that is multiplied by 1 minus 0.5. And let's see how much is that. It is 3 times 0.5, left parenthesis 1 minus 0.5. And indeed, 3 times 0.5 multiplied by 1 minus 0.5 is indeed 0.75. So here you see that the binomial probability distribution variance formula can be established by using the concept of discrete probability distribution variance, whose formula is given by this. This is sometimes called the second moment. Why? Because you're squaring this variation from the mean. X is a number, variation from the mean, difference from the mean, squaring it. Because you're squaring it, it's a second moment, and that is multiplied by the probability of that x value. Okay. So bottom line is sigma square is equal to n times p times 1 minus p, which is the variance, and it is the same as the variance of a discrete probability distribution. Okay. So here we established how the formula for the variance of the binomial distribution comes from the formula for the discrete probability distribution variance. Similarly, the mean of the binomial probability distribution, which is given as mu is equal to n times p, p is the probability of success, can also be established from the mean formula for the discrete probability distribution. Because binomial probability distribution, when you toss a coin, is a special case of discrete probability distribution. As I showed here, it's discrete because there's a discrete number of jumps in the number of heads. Okay, I stop here. I've talked a lot, thrown a lot of concept. I'm sure you will have some questions. Please do not hesitate to ask me a question by writing a note in the comment section. I will answer to each one of your question. Okay, so I appreciate your time, and if you like this video, please give me a thumbs up. That really motivates me to produce some more interesting videos just for you. Again, if you like this video, share with your friends. You and your friends please subscribe to my channel by hitting the red subscribe button, and please at that time click on the bell button, which will notify you every time I upload a new video. Thanks for watching. Take care. Have a nice day. See you next time. Do not forget to watch me tomorrow. Take care. Bye bye.